Imagine this, a customer reports that the product price is still showing the old price. You immediately check the database and the price is having latest value. The update API completed successfully. The database has the latest value. So why is your application still returning the old price? At first, most developers blame the database. Maybe the update failed, maybe the transaction did not commit, maybe replication is delayed, but after checking everything, the database is perfectly fine. The real problem is somewhere else. It's the cache. Let's look at the simple method. Now watch what happens. The first request is exactly what we expect. Spring checks the cache, nothing is found, so it loads the data from the database. Then it stores the result in the cache. Now the same user sends the same request again. Notice something interesting here. This time the database was never called. Your method was not executed. You can prove it by adding the console output. For the first request, the console log will print, and the second request, there is no console log. That means Spring completely skipped your method. It simply returned the cached value. So now the real question becomes, who decided to skip your method? How did Spring know it could return data without touching the database? That is the hidden mechanism behind cacheable annotation. And once you understand that mechanism, cache hits, cache misses, stale data, and most production cache bugs become very easy to understand. In the previous videos, we learned something important. Annotations like transactional and async do not execute by themselves. Spring places a proxy in front of your method. The same thing happens with cacheable annotation. Let's look at the code again. Most developers think every request simply calls the method, but that's not what Spring actually does. Before your method is executed, the request first reaches the Spring proxy. The proxy checks whether the data is already available in the cache. Let's watch two requests, the first request and then the second request for the same product. Now let's understand what's happening. During the first request, the proxy checks the cache. Nothing is found. This is called a cache miss. So Spring executes your method loads the product from the database. The proxy stores the result in the cache and returns it to the client. Now the same request comes again. The proxy checks the cache one more time. This time the product is already available. This is called a cache hit. So Spring immediately returns the cached value. Notice something important. Your method is never executed. The database is never called. That's why caching makes applications much faster. Don't think of a cacheable annotation as a cache annotation. Think of it as a decision maker. Everything starts making sense now. The proxy decides whether your method should execute or not. If the data is already in the cache, your method is skipped completely. If it is not, Spring executes the method, stores the result and returns it. And once you understand this flow, the next question becomes obvious. What happens if the proxy stores the wrong data, or never removes outdated data, or does not get a chance to intercept the call at all? Those are the production pitfalls we will uncover next. So far we have learned how Spring stores data in the cache. But here is another question. When you request a product, how does Spring know which cache entry to return? Suppose we have this method. You call it from your controller getProduct by ID. Spring stores the result in the cache. Later, you call the same method again. How does Spring know this request belongs to the same cached object? The answer is every cache entry has a unique cache key. Think of the cache like a locker room. Every locker has a unique number. If you know the locker number, you immediately get the correct item. If the locker number is wrong, you will never find the data. The first request stores the product using the key. The next time Spring receives the same key, it immediately returns the cached value. Everything works perfectly, but production applications are rarely this simple. Suppose your application supports multi-tenant. Multi-tenant architecture means you hosted your application using single instance, your database is single instance, but different customers are using. So you should differentiate with your customer ID or tenant ID. So now both tenant A and tenant B request the same product. Both requests generate the same cache key. So Spring assumes they are asking for the same data, but they are not. Different tenants can have different prices, different discounts, or even different products. The cache key is no longer unique. The fix is simple: include everything that makes the data unique. Now the cache entires become each tenant gets its own cached data. No collisions, no incorrect results. So remember this simple rule: the cache is only as good as its key. Your cache key is not unique. Don't blame Spring. Spring is simply returning the entry that matches the key you provided. We have learned how Spring stores data in the cache. Now the next question is, how do we manage that cache? Spring provides 3 annotations. Each one has a different responsibility. Let's understand them one by one. At cacheable annotation. We already know this one. When data is requested, Spring first checks the cache. If the data exists, it returns the cached value. Otherwise, it executes the method, stores the result, and returns it. Use this annotation for read operations. The second one, cache put annotation. Now suppose a product price changes. Instead of removing the cache, you can immediately update it. The next read request gets the latest value directly from the cache. No stale data, no extra database call. The third one, cache evict. Sometimes updating the cache is not necessary. You simply remove the old entry. The next request behaves like a cache miss. Spring loads fresh data from the database and stores it again. Understanding the annotations is only half of the story. Most cache bugs happen because of a few small mistakes. Let's look at the most common ones. Let's go back to the problem we saw at the beginning. The database has the latest value, but users still receive the old value. How is that possible? Spring does not compare the cache with the database. If the cache already contains data, Spring simply returns it. That's why after updating the database, always remember to use either cache put or cache evict. The second pitfall, this bug is surprisingly common. Suppose the product does not exist. The database returns null object. Spring stores that null in the cache. Later, someone creates the product, but the application still returns null because null itself is cached. The fix is simple: do not cache null values. Now Spring stores only valid data. The third one, self-invocation. This should already look familiar. The method call never reaches the Spring proxy. No proxy means no cache. The solution is the same as transactional and async. In the previous video we have done, call the cached method through another Spring bean. One final pitfall, by default, Spring removes the cache after the method completes successfully. Suppose your update method throws an exception. What happens? The cache is not removed because the database update failed, and that's usually the correct behavior. But sometimes you want the cache removed before the method starts. You can use before invocation true. Even if the update fails, the cache has already been removed. Use this carefully because the next request will always reload the data from the database.